Hello, this is Mr. Huber. In this lesson, we're going to talk about arithmetic sequences. Right? A sequence is just a listing of numbers. For it to be considered arithmetic, that means that there's a common difference in the list of numbers. There's the same amount being added or subtracted, if you think about that as adding a negative, over and over and over again. So what we see here, a list of numbers. We want to figure out if it's an arithmetic sequence. That means it's got to have the same difference from one number to the next. So the way you can find out is find the difference. 9 minus 5, that's 4. Okay? And we can go all the way down the list. So that's a difference of 4, 4, 4, 4. So it's a common difference, right? A common difference, common, means it's the same difference, okay, from one number to the next throughout this listing. Okay? Again, always the same difference to be an arithmetic sequence. Okay? So from this, we can determine that yes, it is an arithmetic sequence. Yes. What is the common difference? Okay, the common difference would be 4. We're adding 4 each time. We look at the next listing of numbers. Difference of 4 and 4. So yeah, it looks like it's an arithmetic sequence. And now we're adding 6 and then 6. So this is not a common difference. We have adding 4 and then 6 and then 6. Common. Always the same. Always. Not sometimes the same. Always the same. So is this an arithmetic sequence? No, it is not, because there's not a common difference throughout the entire list of numbers. All right. Arithmetic sequence has a common difference. And that's going to be the key here when we write out some ways to represent these arithmetic sequences. Right? Again, just kind of the definition of what they are. We take a starting value. A is the starting value A, whatever it might be. Then we add the common difference, and then we add the common difference again. Right? That'd be like adding 4 and then 4 again. We've added 8 now to the number we had at the beginning. And then we add 3 common differences to the starting amount, right? So each time you add on another D, you add another common difference on each time to get the next number. There's a definition for this, recursive, recurring. And the word recursive means it's recurring, it's happening over and over and over again, okay? A sub 1, this little 1, it's lowered down, written a little smaller, it's A sub 1, is the same thing as A, that's our starting value, okay? So any number in the sequence, so this n means it could be the 4th number in the sequence, the 5th number in the sequence, whatever it might be. Okay, a sub 1, first number in the sequence. A sub n, any number in the sequence, is the number before it, n minus 1. So if this is the 5th number in the sequence, then we go to 5 minus 1, the 4th number in the sequence, plus the common difference, right? To find the number, you take the number before it and add the common difference. If we go back up to our lists here, okay, how would we find the number 21? This would be the 1, 2, 3, 4, 5. This is a sub 5. To find a sub 5, we take a sub 4 and add the common difference. So we take the number before it and add the common difference. Okay. So keep that in mind, what those notations mean. Okay. A sub n means any number in the sequence. Okay. It could be a sub 50. That'd be the 50th number in the sequence. To find that, we'd take the 49th number in the sequence and add the common difference to it. Okay. Explicit definitions can sometimes be more useful. Up here, if we want to find the 50th term, we have to know term number 49 and add the common difference. So how do we get term 49? We have to know 48, and so on all the way back to term 1. This lets us figure out the 50th number in the sequence, you see, without having to know term n minus 1. This n minus 1 isn't term n minus 1, it's just taking whatever that n is and subtracting 1. So we take our starting amount, an explicit definition here, this is our starting amount, and we add n minus 1 times the common difference. So if we want to find the 5th term in the sequence, we take the first term, and we add 5 minus 1, right, to find if n is 5, we take a 5 here. So 4 times d, the common difference. We take the starting term plus n minus 1 times the common difference. Right? So again, if we wanted to go back up here, and we want to find term a sub 5. Okay, so we're going to do that for this first listing. If we want to find term a sub 5, we take the first term and we add 5 minus 1 times the common difference, which is 4. We could fill in a number for a sub 1. Okay, change that there. That's our 5, right? Our starting amount. Okay? That's a sub 1. This is n minus 1. And that's times d. So to find the fifth term, we take the term we started with 5 plus 4 times 4. That's 5 plus 16, which is 21. It should be, right? The fifth term was 21. Now, if we want to find the 80th term, we could figure out the 80th term by doing a sub 80 equals 5, still the starting amount, plus 80 minus 1 times 4. And that would give us the 80th term in the sequence. Okay? So this explicit definition is particularly useful when we want to find what the value would be of some number in our listing. All right, so let's figure out here the 100th term in this arithmetic sequence. It starts with 112, 109, 106. So to write out and find the 100th term, okay, so to find term 100, we take the starting amount, 112, plus 100 minus 1 times our common difference. What's our common difference? Well, we need to look at our listing here, and we go from 112 to 109 to 106. We're going down 3 each time, so it's negative 3. Right, this is a sub n equals a sub 1, the starting amount, plus n minus 1 times d. Okay? Here we're trying to find the 100th term. So we're trying to find term a sub 100. We take our starting amount, first number in our list, 112, plus n, which in this case is the 100, minus 1, times d. And then we could do the calculation here. So that's going to be 112 plus 99 times negative 3. And you could type this all into your calculator at this point. That's fine. So it would be 112 plus 99 times negative 3. And if you do that properly, you're going to get negative 185. Okay? So the 100th term, a sub 100, is 185, negative 185. Okay? We can find any number term in the sequence. I didn't have to go and find term 99, which would require me to find term 98. Again, you don't have to subtract 3 over and over and over and over 100 times. Okay? To find that 100th term, there's a way we can do that. Now let's look at this next example, the second and third terms of this sequence. So we have the first term, and we have the fourth term. So we have term a sub 1, we have term a sub 4. So what we want to do is find the difference between those. So 38 minus 26 is 12. Okay? So the difference of 12 going from here all the way to here. So that's going 1, 2, 3 numbers. So if I divide that by 3, I'll get 4. Okay? If I add 4 onto 26, I get 30, and then 34, and then I'd have 38. So my common difference was 4. How did I find the common difference? Okay? I took the difference from this term to this term. Doesn't matter how many apart they are. Okay? And I divided by 4 minus 1. There are 3 terms apart. To go from A1 to A sub 4, I've gone 3 terms. So I can figure out common difference. Again, it's got to be the same amount that I'm moving each of those 3 places. So that would be 4. There's my common difference of 4, and I can figure out those 2 middle numbers. Right, you can do that for any listing with any blanks in there that you want to fill out. A brief break. What is alliteration? Well, brief break is alliteration. Alliteration is 2 words that start with the same consonant sound. Okay, same consonant sounds, like brief break. Okay, Dunkin' Donuts is an example of alliteration. So alliteration's a literary device that you can use. What I'd like you to be able to do for me, for some extra credit here, is send me an email with an example of alliteration in the real world, something like Dunkin' Donuts. Don't use that one, but come up with your own. Okay, so send me an example of alliteration before the next class day starts, and you'll get extra credit points for that. All right, let's look at one more guided practice problem. All right, it says the number of seats in each row at a basketball arena form an arithmetic sequence. Row 1 has 8 seats, Row 2 has 10 seats. How many seats are in row 13? Okay, so our listing is going 8 seats and then 10 seats, and then what we want to figure out is row 13, right? So our common difference is 2. So we can write out a sub 13, right, that's what we want to find out, row 13, is equal to 8 plus 13 minus 1 times 2. Right? So we could figure out here how many seats are in row 13. Right? Again, just to go through where we got those numbers from, this is our starting amount, our a sub 1, which is 8. Right? The 13 is our n, that's the number we're looking for in our sequence, the 13th row, minus 1, then times our common difference. Okay? So that's going to be 8 plus 12 times 2. Okay? 8 plus 12 times 2, which comes out to, go back to the pen here, 32 seats. So there'll be 32 seats in row 13. Again, if we start with 8, then 10, we're adding 2 seats every row. So another example of where you can use that explicit formula to be able to find directly a sub 13 in this case. So know what an arithmetic sequence is, where it has a common difference. Understand how to work with that common difference to find different values, and be able to work with finding numbers at the beginning of a sequence, end of a sequence, inside of a sequence. And we'll be continuing to practice those as we go forward.